CATIA V5, how to visualize free space within a model. So I have over here a 5-piston engine, and currently I'm within assembly design. And if I will go over here within section, I will go for the section to be a volume cut. We're gonna see how that model will look in a section. Now, in order to visualize all that free space within a model, we can make use of digital mockup optimizer free space tool, which is available over here. As you can see, for the selection, I can either select the whole assembly in this case, and I can define an accuracy over here. So currently this is set to 1 millimeter, and if I will hit preview, we're gonna see how that mesh would be computed. And over here we have a visual representation of all the free space around the model. If for the accuracy I will increase this, so for example to 5 millimeters, I will hit preview again. We're gonna see how that mesh will look now. We currently see that this has been voxelated, so we have multiple cubes over here, and they will all have 5 millimeter in length. If I will go with something higher, for example 10, this will look even more boxy, as we can see over here. If I will go with something larger, for example 20, the free volume space will look like this. Now, if I will go with a value of 0.1, this will require a little bit of time to process, as you can see over here. So currently CATIA is computing the free space analysis for this engine assembly, but we are still gonna be able to visualize that. And the main advantage of using a smaller value is that it will represent more accurately the free space within the model. So even though CATIA is currently not responding, it should be able to process the free space analysis with an accuracy of 0.1 millimeter for this case study model. So let's take a look. The estimated time is over there 12 seconds, but as we can see, there's a little bit of not responding problem. And at the end, we're gonna see that the accuracy is too small with regards to the product size. Okay, so let's just slightly try to increase that. So 0.6, because with 1 millimeter it worked, therefore it should work fine with 0.6. And as we can see, we're gonna have that mesh represented over here. Just like with the other tools from Demo Kinematics, Demo Optimizer, if you're gonna save this, keep in mind that this will be a triangulated mesh. Therefore, the file format will be CGR WRL model STL, but also for this, it will have the unique file format of a 3D map. But this will be a polygonal mesh. For example, if I will go over here and switch this to the wireframe, for the preview visualization that shouldn't change, but we're gonna see that currently the wireframe will look like this. If I'm gonna save this and open it, we're gonna see the mesh being defined by polygons, since this will be a polygonal mesh. Okay, so I hope you find this video useful. I will position a similar video to the left and a subscribe button to the right. So that's it. Thanks for watching.